Alright, hi guys. So in this video, I want to introduce you to a tool I built. It's called CDCraft, and it's basically a tool that is used to help you simulate real-world change data events in your source system. And in this case, basically, I designed it because I'm currently like working with doing like CDC stuff against PostgreSQL, right? So typically, people would um want to take the log-based like CDC approach to capturing changes in their source system for typically two reasons. The first reason is because maybe they want to be able to react to these changes as soon as they occur, and so they want to build like near real-time pipelines. And then the second reason may not necessarily be about the speed at which they are reacting to the change, but just the fact that they want to be able to track all of the changes that has affected every single record within their source system, right? And so for one of those two reasons, you would typically want to like build a log-based CDC pipeline, right? And now when you are thinking about CDC pipelines, the thing you should know about like your like records in your source system is that they would typically go through different kind of changes within their lifetime. And so there are two kind of changes you have to think about in CDC pipelines. The first one is basically just the mutation of the records. The records that get inserted at some point, can get one to many updates affecting them, and then at some point you may even have to delete those records. That's one. And then depending on the stability of your source system also, the schema or the structure of the data in the source system can evolve over time. There's potential for that to happen. And so the whole idea with CDCraft is to kind of like allow you to be able to simulate this at scale, right? So instead of like writing queries with like fake data and trying to do this, maybe against like 10, 15, 20 columns, like this system is designed to allow you to like just scale out your experiment so you can kind of like simulate this kind of CDC changes, like maybe like for like a million records, 2 million, 300, 500 million records, depending on how you do it. And the way it works is, pretty simple, right? So the first thing it does is it generates a batch of records, and then it inserts that record into the source system. And then optionally, it will basically take a subset of those records, and then it will try to mutate it. So either update it or delete it or even both, right? And then optionally also, it will pretty much try to also like evolve the schema. So after every k number of batches, it will probabilistically try to like determine if it should evolve the schema. And then when it decides that it should evolve the schema, it will either add a new column, or like drop an existing column, and then repeat this whole process of generating a batch, doing the mutations and evolutions on them, and then like going all over again until it pretty much gets to the end. To demonstrate this today, I am basically going to be using a CDC pipeline where we have Postgres as a source. We're going to use Debezium as the source connector to pull out changes or track changes in Postgres and forward them to Kafka. And then Debezium will be running on Kafka Connect. And then we'll have an S3 sync also powered by Kafka Connect that will pick up the changes from the Kafka topic. And then it will basically write those changes into an S3 bucket. But in this case, I'm doing everything locally, and like my S3 or my object storage is going to be MinIO, right? So let's dive into it. So all of the code is on GitHub. I'm going to like put a link somewhere with the video, but then the first thing we would typically want to do is spin up our infrastructure. So I basically have like a Docker Compose file where I have like Zookeeper, Kafka, a schema registry. We have our source database, Postgres, and all of this stuff. And then we also have like Red Panda console, so we can like view all of the data. But then like the first thing I typically want to do when I start this up is to pretty much check if Kafka Connect is up and running. And so like from here I can tell that Kafka Connect is not ready yet. And the way I can also check if I want is to pretty much come here and view the logs, and then I can see like what's really happening. So at this point now, from the logs we can see that like what's happening here is that all of the plugins are being loaded. It takes a little bit of time for it to start up, And so like once it's ready, we can pretty much like, yeah, I think at this point here it started. And so if I exit the logs and then I exit this terminal and I do something like make status again, okay, in this terminal I think, so I can clear this and then I can say make connect status, and then we can see that basically it's there, and then we can check, we can say view connectors, and right now there are no connectors. I mean there's going to be a connector at some point. So like one of the things I love about the way like this particular system is designed, CDCraft, is that it's interactive. So what I'm going to do now is I'm going to run it, right? And then when I run it, I will pretty much first of all create a table in a schema called CDCraft demo, and then I'm going to put yes. It's going to create the table, and then I'll set the replica identity to full, and then it's asking me if I want to do like an initial load, right? Because if you're building CDC pipelines, you also have to think about historical data. And if you're thinking about historical data, just think about it that, oh, you already have your source system and there's data there. And by the time you're using something like Debezium to like start to like stream, you can optionally decide to do what we like to call like a full load or a snapshot. So you take all the existing data in your source system, and then like you kind of like push them as read events into your Kafka topic, and then you start to like listen for changes. So you go from like snapshot mode to like streaming mode, and then you start to listen to those changes. Here, I mean, I can just say no right now that I don't want to do this, and then I can create a publication. I can create a slot, and then basically it's asking me if I want to start the CDC simulation. Just to be sure that like everything is there, we can do something like PSQL. We can basically hit this, and then I can say select count star from CDCraft demo.sales, and then you get 0 records, but that table is actually there. And then also I can exit this, and then I can say make console UI, and then I mean we can see red panda. So we have just like a single Kafka broker. I think we should have only like the config topics here right now, and then we can see like our connect cluster also. So CDCraft, and then there's basically nothing here because we have not created any connector, but you can see all the plugins that is in our system. So what I'm going to do now at this point is I'm going to come back here, and before I start the CDC simulation, what I'm going to do is I'm going to deploy my source connector and my sync connector. So, and you can basically check like the content. I don't want to like go deep into like CDC here because like the main purpose is demoing like CDCraft itself, but then I can say make PG source, and then I'm basically going to use the Kafka Connect API, make a post request there, and then I'm going to like have like a source connector. So if I say make view connectors, now we can see that there's a connector called PGSRC connector, and then if we come back to this place and we refresh, we can basically see now that we have a source connector, and like the connector is healthy and it has one task and the task is also running, right? So it's basically ready to receive like our CDC changes. And then I'm going to open like MinIO also, and I will log in here with MinIO, MinIO 1, 2, 3, and then we have a bucket, like an empty bucket here that's called CDC raw, and there's nothing in that bucket right now. But then like once I start to run it, we're basically going to see data trickle in, right? So since we have like these two things now, I can come back here, and what I can do next is to basically, okay, so since we have like everything up and running, what we can do at this point is to basically also deploy our sync connector. So I'm going to say sync s3 sync, and then like make a push request to the Kafka Connect API again. And if I want to view connectors here, you can see that you have like your PG SRC connector, you have like your s3 sync connector, I named it v1, just prepping before this. But yeah, basically I have those two things now. And if we come back to our UI, and then we come back to connectors, you can see that there are two connectors here. So you have like your PostgreSQL source connector that's powered by Debezium, and then you have like your S3 sync connector, which is like your Confluent S3 sync connector. That's the flavor I'm using. So once I have these two things set up, come here, you can see now that there is this particular topic right now, which is the Debezium CDCraft demo sales topic, but then like there are no records here just yet. And then what happens next is I can basically come back here, and then I can say start the simulation, right? And once I do this, it will start to like generate it. And so what you can see here, it says starting CDC simulation for 1 million records in 2000 batches. So like each batch will generate about 500 records, and then after it generates those 500 records, system will kind of like randomly decide if it wants to do update on like a subset of those records, and if it wants to like mutate a subset of the record also, by doing deletes on them also. And then you can see that after every X number of batches, like the evolution of the schema is happening. So like it's dropping certain columns, and then it's adding certain columns. And then the cool thing about this system is that it's able to track what is being added and what's being dropped, right? And like in another video that I'm going to make, I'm going to pretty much show you how you can kind of like control these columns, right? Like it's not fixed, it's not like specific to my use case. You can build what I call like the data generators for every single column. You can define how the data for that column can be created, and then you can basically like basically control that information and use it to build out your own table. It doesn't have to be sales, it can be anything else. And then you can have like a pool of columns that can be added, and then you can also protect columns that you don't want to be destroyed by this particular process. And so if we go back to this place and then we just refresh here, we see that messages are coming in. And then if I refresh here, we can see like there are a bunch of messages, and like you can there's a flag here that tells you if that record was deleted or not, and then it tells you what the operation is, and here I'm using like a schema registry. So if we also go in the schema registry and we look at like the values, you can see that there's already like 13 versions of the schema for this particular thing. And then if you look in your version diff, you can compare like every single one of them. So you can see here that like certain columns have been dropped. You can see that like certain columns have been added. Basically, you're able to like track all of these things. And I think like that's like really, really cool. So I'm just going to wait for it to get to 2000. And then once it hits 2000, like, we can start trying to like, do our sum checks, right? It's done at this point. But before that, let's come back to S3 and let's like refresh, and now you can see that there is records here in partition 0, and like they are in Parquet, right? So I'm writing them into S3 as Parquet files, and then you have all of these records, right? And so the first thing I want us to do is to pretty much come back here to the topic and then try and make sense of the numbers, right? So here we can see that there's a total of 1,123,350 events that happened, right? So we inserted 1 million records, but then aside from inserting 1 million records, we did some updates, and those updates led to like more events or messages like hitting our Kafka topic. And then also we did some deletes, and those deletes also led to like certain messages hitting our Kafka topic also. So we can try and kind of like validate this number to just make sense of what's happening. So if we come here, we can see that first of all, like the total number of additions in terms of columns is like 7 columns. So in total, we added 7 columns, we dropped 3 columns, and we have configured the maximum adds for like number of columns to be 7 actually, and then the maximum drops to be 3, right? So it's random. It can add all 7 columns. It can add less than 7 columns depending on how the system behaves every single time you run it. And then it can also drop no more than 3 columns, but then it can drop less than 3 columns, right? Because it's probabilistic. But then in this run, it just so happens that like it did all 7 and it did all 3. Then the next thing is you can see what the original schema was, and then you can see the schema changes. So the first thing that happened was a drop, and then there were like all of these adds that happened, and then there was a drop, there was an add, there was a drop. So you can basically see like a summary of the schema changes. And then I mean the cool thing here also is that we can see that like the total inserts is tracked. So there's like 1 million inserts, 58,153 updates, and then 65,197 deletes, right? So like the first thing we want to do is probably just I'm going to spin up DocDB here, and then I'm just going to run like a select statement against DocDB. So I'm just going to do like a select, and then we're going to like just add those numbers together to kind of like verify. So 1 million plus 58,000 plus, and then we now have this also. And so if we add all of this, we get 1123350, which should be 1123350. So we're able to like track all of the changes that has happened, and then we can also see the consumer. And here I mean we're seeing that there's a lag, and this lag is pretty much something I'm still looking into. But then like the explanation is that the way we have configured our sync connector is to pretty much set the flush size to 1000, and until there are like 1000 messages, like it's not going to go. Ideally there should be like 2 parameters or 2 conditions to check. There should be like number of records, and then there should be like a maximum number of time that has to be exceeded, and once that time is exceeded, you know, it's supposed to basically just like flush all the messages, but that's not happening. But then just to show you that like it's pretty much close, if we come back to our system here to like DocDB, right, we can basically just do all of these configurations, and then if we do this, we can basically track the number of creates, number of deletes, and number of updates. And if you compare this number to what you have in the lag here, 540, it will add back up to this particular number, right? So yeah, the whole idea here is that I can use this really awesome cool tool called CDCraft to pretty much simulate CDC events, and I can track like creation of records or insertion of records, updates and deletes, and then I can also evolve my schema also. Hopefully you found this video interesting and helpful. Thank you very much. Cheers.